So what is 0 of a polynomial? 0 of a polynomial is the value of x for which the p of x will be equal to 0, correct? So let's try to understand that with an example, right? So here if you look, 3x squared minus 3x plus 2, right? So here what value of x will make p of x be equal to 0? So you can try out with different values. You can try with 1, 2, 3 and go, and any number, right? -1, -2, any of these numbers. You can put in the value wherever x is there, right? Wherever x is there, I'll put 1 and see. So it'll become 1 squared minus 3 into 1 plus 2. 1 minus 3 is -2. -2 plus 2 is 0, right? So when the polynomial becomes equal to 0, which number or which value of x made that polynomial be equal to 0, that is called 0 of the polynomial. For example, if I have x plus 3, right, p of x is equal to x plus 3, right? So what should I put in x so that p of x will be equal to 0? So I know if I put x is equal to -3, it'll become equal to 0. So p of -3 is what? It'll become 0, right? So what is my 0 of the polynomial? -3 is my 0 of the polynomial. This is the logic of zeros of polynomial, okay? So here we will understand, let's see another example. P of x is equal to 0. So we have x squared minus 3x plus 2. Is there any other number? You can try with 1, you can try with -1, you can try with 2. So there will be how many zeros here? That's an interesting question that we will discuss. How many zeros will be there is based on the degree, okay? So we'll look into that as we discuss the graphs, okay? So all you have to understand is when p of x becomes equal to 0, right, the value of x is 0 of the polynomial. Very simple, okay? Now let's see. So like I said, the graphical representation, okay? So y is equal to x on a graph. So y is equal to x on a graph is shown here. This is y is equal to x. So what are the different points? We can plot the points, right? We understood how to plot the points. If I put x is equal to 1, y will be 1, right? So it can be y is equal to x, or I can say p of x is equal to x, okay? Instead of y, I can say p of x. So polynomial as a function, y means what? Y is the Cartesian coordinate y, right? So the same way I can say p of x, right? P of x is the y. Both are the same, right? Both are the same. It is the function. So in the graph, the y represents p of x, right? And x is the different values. So when I put x is equal to 1 here in this scenario, y is equal to 1, y will become 1. And if I put x is equal to 2, y will become 2, and so on. So like that, you can plot a graph. Different points you will get a graph. So it's a linear graph, right? It's a straight line. Now this is the graphical representation of a linear polynomial, as we had discussed in the previous topic. So it cuts where? It cuts the x-axis at exactly one point, right? So if it cuts exactly at one point, so here if you look, this is the point. What is this point? This point is -2, 0. Is there any height? No. So what do you understand from this point? If this point is -2, 0, that means what is the y value? Y is 0, correct? What is x? X is -2, right? X is -2. So if y is 0, what does that mean? P of x is 0, right? So P of x is equal to 0 when what? When x is equal to -2. This is the logic that should be induced, okay? So what you understand here is P of x is the y. When y becomes equal to 0, what is the x value? X value is -2. So -2 is the 0 of the polynomial, right? -2 is the 0 of the polynomial. So in a linear polynomial, the graph, the straight line, where it touches the exact axis exactly at one point, right? That exact point will be what? The 0 of the polynomial as well. So what is my 0? My 0 is -2. So wherever it touches the x-axis, that point will be your 0 of the polynomial. We'll learn more about it, okay, as we move on. Now for a quadratic polynomial, let's see how it changes, right? So we have ax squared plus bx plus c, right? That is the polynomial function for a quadratic polynomial. So let's write the general form or the standard form, which is ax squared plus bx plus c. So I can write p of x is equal to ax squared plus bx plus c, right? So here if you look, right, how do we understand what shape will the parabola be, right? So all you need to understand is if a is positive, right? If a is positive, then the parabola will be upwards. It will be the U shape, right? Now, if a is negative, then it will be downwards, right? So if a is negative, it will be somewhat like this, right? A is negative, it will become downwards. So it will cut in exactly 2 points at times, right? So this is when there is 2 zeros, right? -2 and 2 is the 0. Or it can be at only 1 point, okay? So if it cuts only 1 point, both the zeros are equal. Both the zeros are 3, 3, okay? There will be always 2 zeros. Why? Because based on the degree, that we'll discuss. So based on the degree, the number of zeros will be same, right? We have learned that before, but I'm saying it again. The degree defines what? The number of zeros. So for a quadratic polynomial, how many zeros are there? The number of zeros will be 2 zeros because degree is 2. So how many zeros will be here? There is 2 zeros, but the only difference is it is the same. 3 and 3 is the 0, right? The zeros are equal. So 2 zeros are there and it will be 3 and 3. Okay, that is the logic. So now what if it does not touch? If it does not touch, we do not have any real zeros, right? We do not have any real zeros. If it does not touch the x-axis, we do not have any zeros, okay? And you can see it is inverted U, right? It is like an arch. So why is this? Because a is negative, right? A is negative. So look for the a value, you'll understand whether it is inverted or a proper U. And look into those points where it touches the x-axis, you can find your zeros, right? In the first figure, it was -2 and 2. These are our zeros. In the second figure, it is 3, 3, which is, and there are no zeros here, right? Because why? It is not touching. You can't say 0 because I just said no zeros, but it is not 0, okay? You can say it is not, there are any zeros, okay? You can't put 0, but there are any zeros. There is no zeros. So this is the logic, okay? Now let's try to understand further. What happens to the graph of the polynomial for x raised to n? What is x raised to n? So well, let's say we have any polynomial y is equal to x raised to n. N is what? N is a whole number. So what is my logic here? For example, you're saying x square, right? Y is equal to x square, right? Y is equal to x raised to 3, x raised to 5 for different n, okay? Different whole numbers. So as n increases, what happens? The graph becomes steeper. What does steeper mean? So it becomes closer to the y-axis, right? So it becomes closer here, correct? It becomes closer here. It'll be closer to the y-axis. As n increases, it'll become closer to the y-axis, okay? So if you look carefully here, this is x square. This color, the pink color is x square. The peach color is what? The peach color is x raised to 7. So x raised to 7 is closer to y than x square, correct? So it becomes closer. As n increases, it becomes closer. Now if n is odd, then what happens? If n is odd, this is what we observed. If n is odd, this is very important, not in terms of exams, okay? In terms of Olympiads, it's very important. That's why I'm explaining this. So you will be done with this topic pretty much, okay? So in terms of Olympiads and test, this is very important. So that's why I'm discussing, okay? So if n is odd, the graph lies in the first and third quadrant, right? So what is the first and third quadrant? Let's revise. So we have the first quadrant, second quadrant, we have the third quadrant, we have the fourth quadrant, right? So if n is odd, if n is an odd number like 3, 5, 7, what happens? It'll be in the first and third quadrant. As you can see, x raised to 7, it is in the first and third quadrant. If n is even, what happens? The graph lies in the first and second quadrant, right? If n is even, the first and second quadrant. So you can see first and second quadrant for x square. Now, the graph of minus x raised to n is the reflection of the graph y is equal to x on the x-axis. So what happens? What is minus x raised to n? It will be an inverted formation here, okay? That is the only logic here. So minus x raised to n is what? The inverted or the reflection, correct? The reflection of the graph of y is equal to x. Whatever y is equal to x, it will be the reflection of it. We have learned into reflection of points, right? The same logic applies to the line. It will be the reflection, as you can see, okay? So this is all about graph of the polynomial of x raised to n. But what you guys need to understand here is where is the zeros of the polynomial? For 1, 0, linear polynomial, the degree is what? The degree is 1, right? If the degree is 1, how many zeros will be there? 1, 0, right? And we can see the 0, how? It's on the x-axis. The point where it touches the x-axis, that point is the 0. Because over there, the y is equal to 0, right? P of x is equal to 0, correct? So P of x becomes equal to 0 means what? Means y is equal to 0. Where is y equal to 0? At the x-axis where the line touches. So that is what you need to understand. So minus 2 is the 0 here. There is only 1 0 in this question, so it is minus 2, right? What about here? What are the 2 zeros we have? we have minus 2 and we have 4, right? Minus 2 and 4. These are the two zeros here, right? A and B. So these are quadratic polynomials, that is degrees 2, 2 zeros. Cubic polynomials, degrees 3, 3 zeros. You can see minus 2, 2 and what? Between 2 and 4, that is 3, right? Yes, so these are the 3 zeros, cubic polynomial. So this is what you have to understand. A, B and A, B, C, these points corresponds to 0 of the polynomial in those graphs. Very simple, right? Okay, so number of zeros in general, polynomial of degree n has at most means maximum that many zeros. A linear polynomial has maximum 1 0. A quadratic polynomial has maximum 2 zeros. A cubic polynomial has maximum 3 zeros. At most means maximum, right? So this is what we understand about polynomials, and it's based on the degree, right? So let's see the 0 of linear polynomial function. Consider a linear polynomial f of x is equal to 16x minus 4. How do you find the 0? The 0 will be when f of x be equal to 0. So equated to 0, right? When f of x is equal to 0, that will be the 0 of the polynomial. So what you need to understand is, let's put that value, right? To find it 0, what you will do? Set f of x is equal to 0. So 16x minus 4 is equal to 0. Solve it. We'll take the minus 4 to the other side. So 16x is equal to 4. X is equal to 4 by 16, which is 1 by 4. So 0 of f of x is 1 by 4. So if you put 1 by 4, the polynomial will be equal to 0. Simple logic. This is how you find zeros of a linear polynomial function. Okay. Now what about zeros of a quadratic polynomial function? There is multiple ways. So we have already learned about splitting the middle term to find the factors. Okay, we're going to do that method. There is also a quadratic formula. There are a lot of methods, but let's understand about factorization of polynomials using splitting the middle terms. Okay, so we have 2x squared minus 5x plus 3, right? How do we split it? This minus 5x, we know 2 into 3 is what? 6. So the product should be 6 and the sum should be equal to minus 5, right? That is what we have learned. 2 into 3 is 6, minus 5 should be the sum. So how do we split it? We can split it as, the middle term can be written as minus 2 plus minus 3, right? Or minus 2x plus minus 3x, right? And the product is 6, so it will be minus 2 into minus 3. So which is 2 into 3, which is 6, right? So that's how you split it. You will split it as minus 2x minus 3x. So we split it. Now we'll group the terms, right? We'll take 2x common outside. If you take 2x common outside, 2x the whole x minus 1. If you take minus 3 common outside, minus 3 the whole x minus 1. Now take x minus 1 outside. So what do we have? We have x minus 1 the whole into 2x minus 3. Now when will this be equal to 0, right? When will p of x be equal to 0? In this algebraic expression, it is two factors. One factor is x minus 1. The second factor is 2x minus 3. Two factors are there. So if I put minus 1 here in place of, if I put 1 there, it'll become 0. 0 into something will give you 0. So when does it become 0? When I put 1, right? It's not minus 1, it'll be plus 1, right? So minus 1 plus 1. So if you put plus 1, it'll become 0. Same way, if you put what here in this x, if I put 3 by 2, 2 will cancel, x minus 3 will become 0. So when does it become 0? When I put x is equal to 1 and when I put x is equal to 3 by 2. So after finding the factors, find the zeros, right? So here the 0 is 1, here the 0 is 3 by 2, right? So that logic. So your zeros will be 1 and 3 by 2, right? This is how you are going to do. We'll do problems and you'll get much more in-depth idea of these questions, okay? All right. We have zeros of quadratic polynomial function using quadratic formula. What is quadratic formula? X is equal to minus b plus minus root of b square minus 4ac by 2a, right? So instead of learning like that, you have to write this formula. This will be much more convenient. What is x? X is equal to minus b plus minus root of d by 2a. First find d, okay? What is d? D is equal to, what is d? B square minus 4ac. So find b square minus 4ac first, then substitute in the formula. That will be easier. You can just substitute these values. Okay, what is a? A is 1. Okay, perfect. What is b? B is 2, right? What is c? C is minus 5. Be careful with the signs, okay? So a is 1, b is 2, and c is minus 5. Substitute these values in the formula and you'll get the answer minus 1 plus minus root 6. So minus 1 plus root 6 is one of the zeros. The other zeros will be minus 1 minus root 6. So these are the zeros of the polynomial function. This is when you're not able to do splitting the middle term, you can use this, right? That is how you have to use this. Otherwise use split in the middle term, okay? All right. Zeros of cubic polynomial function. So for this, we need to use identities. So how do we use identities here? Let's see. So what is a perfect cube identity? That is a plus b the whole cube, right? So what is a plus b the whole cube? It is a cube plus, right? A plus b the whole cube. What will it be? It'll become a cube plus 3a square b plus 3ab square plus b cube, right? This is what we get. Now what is a minus b the whole cube? So observe in this formula what I did. Where will the minus sign change, right? So we have a cube minus 3a square b, right? Then we have we have plus 3ab square minus b cube, right? This is a minus b the whole cube, right? So once you get those factors, once you find out the perfect cube, then it'll be easy for you to like find the factors, then find the zeros. I'll explain this in further. Okay, so you need to be aware of all these identities, the two forms, a plus b the whole cube and a minus b the whole cube. Then the difference of the cube, what is that? A cube minus b cube. What is a cube minus b cube? It is a minus b the whole into a square plus ab plus b square. If you do it like this, what is the benefit? You can find the zeros from here as well, right? There is a factor. So from the factors we find the zero. That is the logic. What is a cube plus b cube? It is a plus b the whole a square minus ab plus b square. So try to learn all the identities. The identity sheet is there in the list of the topics in the sub module. So go through that. If you have any doubts, ask me. Okay. So let us find the zeros of the cubic polynomial fy function of y is equal to y cube minus 2y square minus y plus 2. Okay, so f of y is equal to 0. So y cube minus 2y square minus y plus 2 is equal to 0. So what do? We do grouping. Okay, here what we're going to do, we're going to group the terms. So from this, what I'm going to do, I'm going to take a y common. From where? I'll be taking from here, right? From here I'll take a y common. So I have y square outside into y minus 2. I'll take minus 1 outside from here. I have minus 1 outside, and inside it is y minus 2. So from here we can take what common? We can take y minus 2 outside common. So it'll become y square minus 1. I'm taking y minus 2 outside. So it'll become y square minus 1. You can write the 1 here, okay? So there is no confusion. Y square minus 1 the whole into y minus 2, right? So what is this? Y square minus 1. A square minus b. A square minus b square. Very simple. That is a plus b into a minus b, right? The same logic is being applied here. So what is a plus b into a minus b? It will be y plus 1 into y minus 1. Very simple. And we have y minus 2. Now we got all the zeros. If I put y is equal to 1, it will become 0, right? If I put y is equal to minus 1 in the first factor y plus 1, it will become 0. If I put y is equal to 1 in the second factor, it will become 0. If I put y is equal to 2 in the third factor, it will become 0, right? So what are your zeros? Your zeros are 1, minus 1 and 2. So these are the zeros of the polynomial function 1, minus 1 and 2, okay? So cubic polynomial we understood. What are the important identities that you need to learn are as follows: a plus b the whole cube, a minus b the whole a cube minus b cube, a plus a minus b the whole cube, cube plus b cube, which is a plus b into a square minus ab plus b square. So all of these cubic identities you need to learn. I have an identity sheet as I explained. Please go through them, okay? Then we have these identities as well, which is important: a plus b the whole square, a minus b the whole square, x plus a into x plus b, a square minus b square. All these 4 identities of quadratic is also important, okay? So quadratic identities, cubic identity, and there are special identities which we'll be discussing soon, okay? When the question comes, we'll discuss that. That is much better, so you'll understand it much better.